Okay. Any questions on what we're doing? No. Yes. Mariah, yes.
No.
No. It's too confusing. Is it a yes or a no? It's a no. Quick.
We do 77.
77.
Oh, wait, actually, my book.
Okay.
Oh, I didn't ask. Yeah, that's good. Because I have no idea the problems. I was going to start, but I couldn't remember the problems. So.
Okay, but you have your book. It's good.
Okay, my question
Yeah.
was, suppose that f is invertible and twice differentiable.
F is invertible and twice differentiable.
And f of c equals gamma,
F of C is some
and
number.
f prime of c is not equal to 0.
Prime of C.
Show that f inverse 2 prime of gamma equals negative f. Equals f double prime, negative f double prime c over
Wait. Negative F double prime C
over f prime c cubed.
F prime C quantity cubed. I have no idea. I have no idea offhand, but let's think about it. Right. So this is the right. Is this? It's right as
2 primes.
2 primes. Oh, okay. Okay. Then I might have some idea.
Is there a prime and bottom?
No. Yes.
Yeah.
Sorry.
Okay. Okay. Things are looking better. Okay. So, did anyone have any idea about this?
No.
Anyone have any idea?
It's like the reciprocal function, or is this a reciprocal?
Yeah. You remember. Right? You remember. You have some fact about the derivative. Can you? Okay. So let me ask this. Can you tell me about the first derivative? Can you tell me about the first derivative? Say. Yes, you can.
Invertible.
You have an invertible function. Can you tell me about the derivative of the inverse at gamma, if f of c is gamma?
Maybe 1 over. Or,
Yeah, you remember you have, let's see, so f inverse of gamma is just gamma. Right, let me say it like this. F inverse of x is x. Right, and so we were, in case you forget, you remember that if you take the derivative of the left side, right, and the derivative of the right side, you get that this is equal to 1, and you get that f inverse prime gamma is 1 over f prime f inverse of x. F inverse prime of x is 1 over f prime f inverse of x, right? Right? Okay. So so what can you do with it from there?
So you find the derivative of that.
You can take the derivative of that, right? So I don't know how you want to do it. You could either do it from here, like you're looking for the second derivative, so you take the derivatives of both sides, right? And you end up with whatever that is. Or since this is the section on implicit differentiation, maybe you could just differentiate this one. It's the same thing. Anyway, however you want to do it. So let's differentiate this, right? Because you're looking for f the second derivative of f. So let's differentiate this, right? What do you get? The derivative of the left side plus the derivative of the right side. What's the derivative of the right side?
So there you can use reciprocal rule. So it'd be like negative. What would be like negative that quantity on top?
So this is right. This is f prime f inverse x quantity to the negative 1, say, to the negative 1, and so you get negative this quantity, right? Negative this quantity to the negative 2 times.
Wait, wouldn't it just be over the bottom quantity square?
Oh, do you want to use the quotient rule? Is that what you're doing?
Yeah.
So I was using the power rule,
Okay.
but if you want to use the quotient,
Oh,
you can use the quotient rule, right? So, sorry, I'm just going to use. I'm going to use the power rule to negative 2. Like you have something, you have some function of x to the negative 1. So the derivative of that using the chain rule is negative blah to the negative 2 times what? The derivative of the inside, right? So what's the derivative of the inside? Should I let you try it? Take half a minute to write down the derivative of the inside here. Okay. Do you want to say it, Mariah? No, you don't.
No.
Okay. Everybody, turn to somebody nearby and say, "This is what I think the derivative of the inside is."
Whatever this thing was.
Yeah.
This is the same thing as this. So like find the derivative versus what
Yeah. Oh, yeah. I guess it's just like
just for, yeah.
It's this thing, perhaps you Okay, what's the derivative of this? Right? You have this composition function. You have this composition function. What's the derivative of it? You're going to take. You have this composition, right? F composed with F inverse, right? So using the chain rule, you take the derivative of the outside guy, evaluated at the inside guy, times the derivative of the inside guy, right? Well, the derivative of F inverse, we already got it, right? Derivative of F inverse is 1 over F prime F inverse x. Right. Okay. So all together, what do we get? F inverse double prime is F. I'm going to take this term, right? F double prime F inverse of x. Everything over. Sorry, I need a negative sign here. F prime at F inverse x. Quantity cubed. Right? Right? You've got this thing to the minus 2. You've got this, and you have the same thing to the minus 1 over here. Right? And so you've got this thing to the minus 3. Yeah, Mariah.
Wait, sorry, can you say what each of the 3 blocks was again?
Yeah. Right. So this thing is the numerator.
Okay.
And the other 2 things are the denominator.
Okay.
Right? Because this thing is you move, this is to the minus 2, so I move it to the denominator with a square. But there's already one of those guys on the denominator, so I'm going to have the cube of it on the denominator. Right? What I have is negative something to the minus 2 times something times 1 over that something. Right? So that's going to be negative b over a cubed. Right? This is the a to the minus 2. This is the b, and this is the 1 over a. Right? These terms are the same, right?
Yeah. Then the last 2 terms, the f double prime, f down.
Yeah.
So that's the derivative of the, wait, what is it, where'd you get that one again?
That's right here.
Or like from over there?
Oh, that's from the chain rule.
Yeah.
Right?
Okay.
Because,
And you leave the inside function.
right.
Okay.
So remember we're differentiating this, right? So you get negative this to the minus 2 times the derivative of the inside, right? We have something, to the minus 1, and the derivative of that is going to be negative 1 times this to the minus 2 times the derivative of that inside, right? So here you have it, negative the something to the minus 2 times the derivative of the inside by the chain.
The whole thing is the derivative. Okay.
By the chain.
Yeah.
Okay. Okay. So that's it, right? There you have it. That's exactly this thing here, right? Your x is gamma, your f inverse x is c, right? Your x is gamma, f inverse x is c. Okay, so right, not again, not I think not beyond your ability, but you just have to put things together, right? You say, well, here's this thing. They're asking me about the second derivative of the inverse function. You say, okay, well, I know you remember, you know something about the first derivative of the inverse function, and then how do you get the second derivative? Well, you just differentiate one more time, right? And then after that, it's just the chain rule. The power rule plus chain rule plus knowledge of the derivative of the inverse. Okay. But it's actually not complicated. Yes, Claire.
How do you get the C? Like, and
Yeah.
the actual says F prime,
Yeah.
I think it's gamma.
Yeah.
How do you get the gamma and the C?
Well, so let x. So here you have this formula, right? And so if x is gamma, right? X is gamma. Let me write it out with x equal gamma.
Okay.
F gamma equals double prime f inverse gamma. Well, what's f inverse of gamma?
Oh, it's C.
It's c.
Okay.
F prime f inverse gamma. Right? F of c is gamma, f inverse gamma is c. Okay. So, with this sort of problem, a lot of the difficulty is just to keep on going, right? You think, oh, this isn't going to work, but you just keep on going and see if something happens. And if that doesn't work, then you try something else. Yeah. But it ought to work. Okay. Yeah. The main thing that this problem teaches you is that to persist, right? It's not all of these things are known to you, right? All of these things are known to you. The derivative of the inverse is this, and so you take the second derivative. How do you take the second derivative? Well, you use either the quotient rule or the power rule plus the chain rule, right? And that's all. Okay. So there's one thing that I didn't mention last time, but I'm not really sure if it's that important to mention. But let's do it anyway. We did implicit differentiation last time, and that showed us, you had some equation for some graph, right? You had some equation for some graph, and somebody was asking you for the first derivative of the function of y with respect to x, at some point, right? And we did this by taking the equation for the graph, expressing y as a function of x, and then differentiating, right? So the only thing that I forgot to mention last time was that you can keep on going and get higher derivatives in the same way. Okay. So maybe you've seen this already. Do people want to see this?
I think that we did it in the homework.
You did it in the homework. Okay. So maybe sort of do you still want to see it, or will you feel sort of like angry to see it now? Close your eyes, please. Raise a finger if you'd like to see it now. Oh, okay. So there's it's a minority, but okay. So so here is a yeah, we didn't have time to do it, but anyway, hope it wasn't too painful. Okay, so here's an example, and somebody say what's y double prime at the point 1, 2. Okay, so how do you do it? You've already seen it. How do you do it? How do you get the first derivative? Power rule. Okay, so you say, well, look, I'm going to differentiate everything with respect to x, right? So I'm going to differentiate everything with respect to x, right? And so what do you get? You get the first guy times the derivative of the second guy plus the derivative of the first guy times the second guy. And then the derivative of x is just 1. Right?
Why is there a plus 1 in the case just?
So we'll differentiate this term first, right? We'll differentiate this term, and we'll differentiate this term, right? So let's do the easy parts first. Differentiating 17 just gives you 0. Differentiating the x gives you a 1, right?
Yeah.
This x turns into 1, the 17 turns into 0. Okay, and then the only thing left is this one. Differentiate this. Use the product rule. Excuse me. Right. So you do the first guy times the derivative of the second. That's going to be 4y cubed y prime. Right. Is that okay? And then the derivative of the first guy, 1 times the second, which is y to the 4. Okay. Right. And from there, if you need to calculate y prime, you can. Right. Y prime, you see that, let's see, y is 2, so you get 8, 32, 1, 32 y prime, 32 y prime, plus y to the 4th plus 16 plus 1 equals 0. Right? So y prime equals negative 17 over 32.
Where did that 16 come from?
You asked about this point, 1 comma 2. And so you just plug in 1 for x and 2 for y. Okay. Okay, and if you wanted the second derivative, what do?
The derivative.
You just take the derivative again, right? Okay, so it's a pain, but you can do it, right? So you say, okay, I'm going to differentiate this thing, this whole thing with respect to x. Right? Again, you get the 0, you get 0 here. The y to the 4th becomes 4y cubed y prime. Right? And the only kind of pain in the neck term is this one. But again, you use the product rule multiple times. Right? So let's do that on the side. The derivative of 4x y cubed y prime. I'm going to move the 4 out. Okay, so you got the first thing times the derivative of the second thing plus the derivative of the first thing, which is 1, times the second thing, which is y cubed y prime. right, by the product rule. First, I'm dividing this thing into two parts. Right? You could do it some other way, but this is how I'm going to do it. This is my first part. This is my second part. First guy times the derivative of the second guy plus the derivative of the first guy 1 times the second guy. Right. Okay. Anyone confused? Yeah. Okay. And then you differentiate this, right? So you know how to do it. The derivative of the first guy, the derivative of the first guy times the second guy plus the, sorry, I should say it the other way. First guy times the derivative of the second guy plus the derivative of the first guy times the second guy.
Wait, why did you take out that x?
Why is the x out here?
Yes.
That's a product rule, right? So you're differentiating a product, this times this, and so you get the first guy times the derivative of the second guy plus the derivative of the first guy times the second guy. Right? So it's just a product rule. Okay. But then this derivative of the second guy also involves the product rule. So we have to do the product rule again. And so that's what you get for the derivative of x, y cubed, y prime, and there are 4 of them. So let's put that back in, and you get 4xy cubed y double prime plus 12y squared y prime plus y cubed y prime plus 4y cubed y prime equals 0. Okay, again, plugging things in, what you get is at 1, 2, right? At 1, 2, you get, well, so you get 32 y double prime plus 48, right? 4 times 12 is 48. Y prime squared, so y prime, remember, was negative 17 over 32, right? Plus y cubed times y prime plus 4 y cubed y prime. I should have put those together, but it doesn't matter. 4 y cubed y prime equals 0. Yeah, go ahead.
In the step before that,
Yeah.
so when you're differentiating over here, isn't the x, don't you multiply the second term also by the x?
No. Because remember, the first guy times the derivative of the second
Right, but
plus the derivative of the first guy.
Yeah, no, but
times
below,
Yes.
you have like a,
Did I mess up?
I think you might have forgotten.
Yeah.
that.
Okay, thank you. Okay.
Yeah.
Yeah, thanks. So there should be an x here. Thank you.
Mhm.
But fortunately, x is 1. So. Okay, and then the question is, what's y prime? And here you have this thing, 32 y prime. What is y double prime? Well, you have 32 y double prime plus some number is 0. You move the number to the other side and divide by 32, and you get y double prime. Okay, so there's nothing. There's actually no new idea involved here. Right? It's simply you take, to figure out what the first derivative is, you take the derivative of the graph, right? The equation for the graph. To figure out what the second derivative is, you take the derivative of that equation, and you get a relation. You get a relation between the second derivative, the first derivative, and the coordinates. So it's not. Again, this is not at all. There's no new idea involved here. It's simply a matter of persistence. Okay. Any questions?
Wait, so for
Yeah.
Okay, yeah. So for y you use 2, and then y prime you use 17 over 32.
Yeah, because you already worked out what y prime was at 1, 2. yeah, that's the only thing that maybe is a little bit, you have to think slightly. Not that much.
Yeah, so
Sarah.
when we're like doing a problem like this,
Yeah.
do we have to like is it always like gonna require that we solve for y prime and then
Well, the thing is that you do need y prime, right? In order to get a number for y double prime, right? Y double prime is expressed in terms of x, y, and y prime. So you have to have it, right? Yeah. Okay. 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 Okay, let's go on to the next section, 3.9, approximation of functions. Okay. Okay, so okay, somebody give me a number between 1 and 100.
72.
What?
72.
72. Okay, so I'm going to guess that the square root is something like 8.5. Okay, that's my guess. Could somebody pull out a calculator and check this guess? Okay, square root of 72 is something like 8.5.
Wow.
What's the answer?
8.48.
8.48. What? It's 8.48.
5.
5. Something like that. Okay, so we're off by less than 0.15, 0.015. Right. Okay, that makes me feel a little bit better about myself. Sometimes when I'm down, this is a good way to cheer yourself up. Just sit around and calculate square roots. Yeah, so I used to do this when I was driving, and my mom would say, "Stop calculating. Are you calculating something? Pay attention to the road." Yeah, it's sort of interesting. It may be that square roots are the thing that got me interested in math, because when I was young, my back when you didn't really have calculators readily available, how did you get a square root? Well, there's actually a book of square roots. And so my dad, when I was young, gave me this book, and it had like all these tables of numbers in it. It said like the square root of 1 is 1, the square root of 2 is 1.4142, the square root of 3 is 1.732, 7321, the square root of 4, blah, 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 you know, like blah, blah, blah. And then when I was around 6 or so, we got a calculator. And so I started putting in these numbers, like 1.4142, and I squared it, and I didn't get 2. So, what's going on here? And so I started like trying to fix the numbers, right? Like adding on. Okay, if I added on a number, does that make it better or worse? Oh, I'm too high now. You know, I have to go a bit lower. And I started like putting down all these tables of what were more accurate approximations of the square root. Of the actual square roots. Yeah. Yeah. Of course, you have to go on forever to get the actual thing, right? But yeah. Yeah. So I don't know. Maybe you can do this with your own children. Another thing my dad did was he had us graph stock market prices, stock prices. So every day we get the newspaper and go to the business section, and then like plot these graphs and put them on the wall. Yeah. Anyway, so just for fun, let me show you something. This is nothing to do with what you're doing right now, but I'll show you something fun, which is what I just used, which is called the Babylonian algorithm for calculating square roots. Okay. So just now, Stefano said square root of 72, and inside I said, all right, square root of 72. That's sort of an easy one. Okay, so the Babylonians had this idea. So this is just for fun, although it does actually lead into the approximation of functions, right? You're trying to approximate the square root function. And the Babylonian algorithm says you do this. You say, well, look, if I'm looking for the square root of 72, I'm really looking for the length of a side, right, of a square whose area is 72, right? I'd like to have a square whose area is 72, and I'd like to know the length of that, right? So the first thing you do is make a guess. So my guess, you look at this and you say, well, I'm going to guess 8, right? I'm going to guess 8 because that's pretty close by. You make a guess. 8. Okay. I'm saying, okay, 8, I know 8 is too short. 8 is too short. So my rectangle, if I have a rectangle of area 72, then here I have 72 eighths, right? That's to say 8. That's to say 9. Right. Right. So I know that I know that 8 is too short, right? And if I try to make an object, a rectangular object with one side 8, then the other side is too long, right? And so you say, okay, so my first guess is too short. I know that the actual length is going to be somewhere between these two lengths, right? This one is too long. If this one is too short, then this one is too long, right? So my second guess is going to be just 8 plus 9 over 2. That's to say 8.5. Right. So that's your first guess. And you can keep on going, right? You could say, well, then my next guess, if my next guess is 8.5, and so you take, this would be, this length is 72 over 8.5, right? And you take the average of these things, and that will give you something even better, right? Because this one is actually too long by a little bit, and this one will be actually too short by a little bit. But when you average them, you'll get something a little closer, right? And you can keep on going. Should I give you one just to try it out?
Sure.
Choose a number, anybody.
57.
57. Okay, so 57 it is. Okay. Okay, so give it a shot. Try and use the Babylonian algorithm to get the square root of 57. Oops. Okay, sorry to interrupt, but let's do it together. Say, what would you like to take as your guess? 7? Okay, yeah, 7 is good, right? So you take 7, right? And then the other side of the rectangle is going to be 57 over 7, right? Let's just say 7 and 8/7, right? And then you average them, right? 7, what's in the middle of 7 and 7 and 8/7? Well, it'll be 7 and 4/2, right? Of course. So 7 plus 7 and 8/7 divided by 2 is going to be 7 and 4/7, right? That's 7.257. Yeah, like this. So if you, Mariah, if I can trouble you again to give us the actual, did you do it?
Yeah.
Oh, okay.
7.549.
7.549. 7.549. So you're off by 0.02 something. Okay. So anyway, if you ever feel depressed, here's one thing that always cheers me up.
Is it actually Babylonian?
Apparently, yeah. Yeah. So it's several thousand, a couple thousand years old, a few thousand years old. Okay. So do we have time to do the actual lesson? Okay. So here's sort of a different different way of thinking about it, more related to the what we're doing right now. Okay. So somebody asks you, say, suppose you have the square root function, or suppose you have any function, but in our example we'll use the square root function, and somebody says, I'd like to know the square root of 101. Okay. Or maybe we should use 57 because that was what we just used. Okay. I'd like to know the square root of 57, right? And you don't have anything available, but you do have your knowledge of derivatives, right? Of differentiability. You know that this function is differentiable, and so you know that it's well approximated by lines, well approximated by tangent lines. Okay. And you think, where is a nearby tangent line that I can use? Is there any nearby tangent line that I can easily calculate? Well, the nearest one would be at 49, right? Because you know what the square root of 49 is, right? That's 7, right? And you can figure out the slope. What's the slope there? Well, the derivative is 1/2 x to the negative 1/2, right? 1 over 2 square roots of x, right? So what's the slope there? What's 1 over 14, right? So f prime at 49 is 1 over 14, right? So you know the slope. You know that there's this tangent line nearby, right? That has slope 1 over 14, right? Okay. And so you say, okay, I don't know the actual value of 57, but it's easy, it's not difficult for me to figure out the value of the tangent line at 57, right? What's going to be the value of the tangent line at 57? Well, I'm stepping over 8 steps, and my slope is 1/14, right? So my original height was 7. I'm stepping over 8 steps. My height here is going to be what? 7 and 8/14. Let's just say 7 and 4/7. Okay, so that gives you your guess. You guess that your approximation is that f at 57 is something like 7 and 4/7, and we just saw that's pretty close. Just one second. So you can write this a little bit more clearly by saying that the tangent line at x equals 49 is y minus 7 equals 1 over 14 x minus 49. Right. So y equals 7 plus 1 over 14. X minus 49. So at x equals 57, y equals 7 and 8/14. This is 7 and 4/7. Okay. So the idea of this approximation, this should properly be called linear approximation. So you have some function, and you're trying to figure out you have some function, and you're trying to figure out the value at some point. Well, maybe that's hard to do, but maybe at some nearby point you can get the tangent line, and then you use the tangent line and say, well, the tangent line's values are easy to calculate, and then you find it. Okay. So. So, of course, this is something that we mentioned earlier, right? F prime c is the limit as x goes to c of f of x minus f of c over x minus c, right? so f prime c is basically f of x minus f of c over x minus c. And so f of x is basically f prime c times x minus c plus f of c. Which is the tangent line at C. Yeah,
Can
right.
you just, to like be more accurate and you're really messy with me, can you just do 1 over 2 times square root of 7, or no, sorry, 1 over 2 times 7 and 4/7, and like get the actual slope? Well, because like here you're assuming the slope is 14, 1 over 14, right?
You find out that the slope at 49 is 1 over 14.
And you're
yeah.
using that for
Yeah.
57.
Yeah, that's right. So and you know, it's a little bit too high, but
Yeah.
it's a little bit too high, but it's not that bad.
Okay. And if you know that the square root of 57 is 7 and 4/7, though.
But you don't.
Oh. Okay.
You don't know that.
Okay. Oh, okay.
Right, that's only your guess.
The approximation.
That's your approximation, which is actually a little bit too high.
Yeah. Okay.
Okay. So this is basically, you know, you don't know something,
Mhm.
but there's some nearby point for which the tangent line is easily calculated. Okay. Let me do another example. So say f of x is 1 plus x to the p. Okay, for some p greater than 0, say. Okay. Right. Somebody wants you to calculate 1 plus 1.01 to the 1,000. Say, what's 1.01 to the 1,000? Okay. So okay. So we're gonna let's take the tangent line at x equals 0. Okay, at 0, right? This thing is 1, right? And let's figure out the slope. What's the slope there? What do we need to do? F prime x is what? It's too easy. P 1 plus x to the p minus 1, right? Times the derivative of the inside, which is 1. Right? Okay, so at x equals 0, f prime is what? Well, it's just p. Right? Because we put in a 0 here, we get p times 1 to the some power, which is just 1. Okay. So what's the equation of the equation of the tangent line? Which is also called the linearization of f. The linearization of f. What's the equation of the tangent line? Somebody tell it to me. Y minus the y value, which is 1. No, it's 1. Right? If you put in x equals 0, what's f? F is going to be 1. Y minus 1 is equal to p x minus 0. Right? And so you get y equals px plus 1. Okay, so what's that say? That says that 1 plus x to the p is basically 1 plus px. Right. Here's the linearization of this function for x near 0. Right? This is the linearization at x equals 0. Okay. So if somebody asked you, say, what's 1.03 cubed? Right? What's 1.03 cubed? What would be your answer? I talk too much to you, Mariah. Kelly?
4.0.
No. So you've got 1 plus 0.03 cubed. This is going to be basically 1 plus 3. Yeah, so this will be basically 1.09. Okay. Or if somebody said, what's this to the 15th? Well, that would be 1.45. Okay. So that's kind of cool. How you can calculate arbitrary powers of small numbers near 1. Numbers near 1. Okay. Let me quickly do one last example, which is important. If you have f of x being the sine function, and somebody is asking you for values near 0, okay. Again, all you need to do is find the tangent line. Right? What's the tangent line? Well, f prime is the cosine. F prime of 0 is going to be cosine of 0. Cosine of 0 is 1. Yeah. Cosine of 0 is 1. Okay. And so, right, and you know that f at 0 is 0, right? The sine of 0 is 0. And so what's the equation of the tangent line? Y minus the y value equals 1x minus the x coordinate. Right, which is to say y equals x. Right, so the tangent line, what's it saying? That sine x is basically x near x equals 0. Okay, so if somebody asks you, what is the sine of pi over 100? Say, well, then you can say, well, it's about pi over 100. Okay. Am I doing office hours on Friday? I'm not sure because my wife wants me to do something on Friday. And my son wants me to put something together like every day. We bought a jungle gym. And he's like, I want you to put the jungle gym together. It came yesterday. He's like, I want you to put it together right now. No, I can't do it right now. So this morning he woke up, I want you to put the jungle gym together today. I don't think I can do it today. So let me think about that. Yeah, I probably, maybe no. Do you want to meet on Friday? Would you like to meet on Friday?
I would, but I could do it a different time.